Now we're going to talk about graphing trig functions. You can graph them on your calculator. You would change the mode from degree mode to radian mode, and we will look at these in class. The biggest thing is you have to remember to change it back to degree mode after you're done graphing, because otherwise you're going to do your other trig problems in the wrong mode and get the wrong answer. All right, so we're going to start with a unit circle. You don't need to draw this on your paper. Okay, so we have our unit circle. We're going to graph the sine function. First, I'm going to label my graph. I do every 3 lines. You're going to see why in a couple days when we do some shifting. So I make this 90, 180, 270, and 360. Again, I'm putting it in radian form, pi over 2, pi, 3 pi over 2, and 2 pi. I did every 2 lines to represent 1 and negative 1. So very simply, we're going to go around this circle and graph the points. When x is 0, my sine curve is 0. At 90, my sine curve goes up to 1. Oh, yeah. At 180, 0, and at 270, negative 1, back to 360 or 2 pi, and at 0 again. So the points were 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, 2 pi, 0. And that's your basic sine curve. Now let's talk about if we change the amplitude. Okay, amplitude is the height. Okay, amplitude is the height. So let's look at this second graph. Basically what this tells us is the amplitude is 2, which means the height changes from 1 and negative 1 to 2 and negative 2. So it's really easy. Wherever there's a 0, it's still 0, because 0 times any number is 0. Where it's 1, go up to 2. Where it's negative 1, go down to negative 2. So as you can see, now our graph goes up to 2 and down to negative 2. So the amplitude is 2, or the height has changed. Let's do the cosine curve, next page. Okay, cosine, x values. So 1, 0, negative 1, 0, back to 1. Same thing, every 3 lines represents 90 degrees. Negative 1, positive 1. 1, 0, negative 1, 0, 1. And that's your basic cosine curve. Amplitude is always a positive number. So we have a negative 3 in front here. So in this one, our amplitude is 3. So up to 1, or up to 3, sorry, and down to negative 3. However, the negative tells us to change direction. So again, zeros are 0. Now, instead of going to 1, we would normally go to 3 with an amplitude of 3, but because of the negative, it means change direction. So instead of going up, we go down. So we start at negative 3. Negative 1, again, change direction, so it would be positive 1, but our amplitude is 3, so go up to 3. Positive 1, down to negative 3. So again, our amplitude is always positive, so we take the absolute value of the number in front of the function. And negative tells us to switch directions. So that's your basic sine and cosine curves and showing you two examples with an amplitude. Now let's look at tangent. Okay, drew the unit circle again, labeled my graph. This time I did it from negative pi over 2, 0, pi over 2, pi. And this is still negative 1 and 1. All right, tangent is the sine over the cosine. So at 0, it's 0 over 1, which is 0. At 90, it's 1 over 0, which is undefined. 0 over negative 1, 0. Negative 1 over 0, undefined. So every 90 degrees, it's either 0 or undefined. So at 0, it's 0. At pi over 2, it's undefined. It's going to be a vertical asymptote. So I'm going to draw in a dotted line. Remember, the dotted line isn't actually part of the graph. It just represents an asymptote. Then it's 0. Do the same thing. Negative pi over 2, amplitude, because it's undefined, negative pi, 0. Okay, so really we don't have any other values. We can look at 30 degrees, 45 degrees, 60 degrees. Okay. If you look at this in the calculator, what's going to happen is as we get really close to pi over 2, our function is going to get really close to the amplitude, or the asymptote. Okay. Okay, so what's going to happen, we can pick these numbers, right? Sine of 30 is square root of 3 over 3. Sine of 45 is 1. Put that one in. Sine of negative 45 is negative 1. And then our values are going to keep going up. So we could calculate all those values and try to plot them. What will happen is the graph will follow the asymptote on both sides. So it would do the same thing here, and then keep going, and here. So that's your tangent function. Now what I want you to do is I want you to get your calculators, change your mode to radian mode, and then graph the tangent function, y equals tan x, and then look at the graph. Because remember, with your calculators, the calculator can't stop writing and then start again. So the asymptotes look like lines as part of the graph. So I want you to look on your calculator and see what it looks like on the calculator versus what it really looks like. Okay? And then I also want you to think about how you're going to graph these other functions. So how would I, in the calculator, graph the cotangent, the cosecant, or the secant? Right? These are the reciprocal functions. So the sine curve and the cosecant curve are reciprocals of each other. So basically, we could go back to our sine graph, right? If I wanted to graph the cosecant, you're going to end up with the 0. The reciprocal of 0 is undefined. 1 is 1. So you're going to see asymptotes again. So I want you to also, besides looking at the tangent function, I want you to clear that out, and then I want you to put in the cotangent function. So when you go to graph it in your calculator, you would put in y equals 1 over tan. And graph that. Take that one out, kind of get an idea of what it looks like. Do the same thing with cosecant, put 1 over sine in, secant, put 1 over cosine in, and look at the 3 graphs. And then in class, we'll look at some more graphs and changing the amplitude and just learning how to graph them without the calculator, but also looking at them in the calculator. Okay, see you in class.